So Joe Cabrera, and I'm going to be talking about building a data processing pipeline in Python. A long title at PyGotham 2015. Awesome. So a quick review of what we're going to be going over today. First, we're going to talk about the problem that we're dealing with. Like, why am I here giving this talk? What is the issue with data right now that we need to solve? And then we're going to talk about our pipeline. We're going to start off talking about the ingestion piece, the parsing next, and then the cleansing next. And then as an add-on, we'll also be talking about, OK, this is cool. I have this awesome system. How do I take what I've built and scale it out to millions of documents across the internet? Because eventually, that's what we want to do with this system. OK, a quick review of the problem. So today, we have data that's pretty poorly formatted. This is an example of one of the documents that I use in my system. And what it is it's an XML-ish type of format called XBRL, used to transmit financial information. And as you can see, we have some HTML mixed in here. So there's some HTML mixed in with some XML. And it's very confusing. And there's a lot of errors in these type of documents. This is not good. Another example of one of the pieces of data I work with. This isn't even XML. What is this, guys? Like, there's some spaces. We know it's Twitter's financial information. But yeah, it's horrible. I can't parse this. There's no parser out there that'll read this naturally. What we would like is data to look like this. Wow, this is awesome. We have the tag name. We have the function name, representation, what quarter it's from. Here's the actual data points, the precision, the quarter, start date, end date. That's what we want. I can't manipulate data until it's in this form right here. And it's largely dispersed across the web. I need to get data from Setar. I need to get data from Edgar. These are both filing sites. So they have the filings for financial companies. And I also want to get data from the US Treasury and a couple of other services. But it's not all in one place. There's not some nice API out there on the web to get all this data. That's a problem. Right now, there's a couple of different libraries out there in the Python community that allow you to deal with data. Two of the ones you're probably familiar with is Pandas, which allows you to manipulate data in what's called data frames. Another problem with this is that it also expects data to be in this nice format already. So Pandas has a specific function to allow you to load in data via CSV. But to even get data close to what I need to put in, it needs to already be processed. There's no way that Pandas understands how to read an XML file. It doesn't understand how to read HTML. It doesn't understand how to read these type of esoteric formats. There's another project out there you may not be as familiar with called Bubbles. That's a kind of data processing framework. But again, it's the same problem. They expect the data to already be in some nice format for you. And that's not what you're given most of the time. So let's look at our data processing pipeline. There's a couple of key steps we have here. First, we need to download all the data, or whatever our ingestion flow is going to be. In our case, we're just downloading documents. Then we need to actually parse that data, right? So we need to transform it from this horrible format into this beautiful format that I can actually read and manipulate with. And then at some point, I'm going to want to store that data. I want to use it later. And then I'm going to clean the data, because it's great that we have all this raw data. But a lot of times, as we talked about earlier, there's a lot of errors in this data. And so we need to do some kind of cleansing process on it. Let's go right into it. So data ingestion. This is the first piece of our processing pipeline. We're going to use two different libraries in Python. First, we're going to use request, because it's really easy to send the required parameters. It's got all these nice functionality in there to make it very, very easy for us to make the request and pull down the data we need. And then we're also going to use something that you may or may not be familiar with, but it's concurrent futures. If you've done anything with Python 3, you know there's this awesome new functionality called concurrent futures. And it allows for this asynchronous execution. OK, what kind of parsers are we going to use? there's a couple of different solutions we have. We can use Python tokenize, which allows us to actually build a parser. This could be very useful if it's not a very standard format, so that the original format that we saw where it was not even anything close to HTML, XML, doesn't even have tags potentially, you might want to build your own tokenizer. And you can do this with Python tokenize. And then also BeautifulSoup. And we're going to get a lot into BeautifulSoup today, because BeautifulSoup is awesome. If you're not familiar with it, it's a really awesome library for web scraping. So if you have HTML, you have XML files, you can scrape through that document. It's awesome. Why are we using BeautifulSoup? It's a lot more forgiving than standard XML and HTML libraries. If you use the off-the-shelf library that's provided in Python for reading XML files, it's going to throw a lot of errors. If you've dealt with it before, you know it throws a lot of errors. It does not like the fact that you're not dealing with correctly formatted information. And so it's going to allow us to not have to deal about those errors, and we can actually rip out the data directly with regex. It's a very brute force method for taking the data out, but it's going to work. And then another important thing to pick up on is that we're going to be using Celery. Why do we want to use Celery? Because it's cool. We're parsing one document. Awesome. We want to parse millions of documents, not just one. So we need a solution for that. And our Celery process will have a couple of different tasks. A task for the download, a task for the parse, and a task for the cleanse. And Celery makes it very easy for us to set up these tasks. So once we've parsed all the data, awesome. We've stored all the raw data into our data store, into a flat file, whatever format we want to store it in, that we can understand and read. Now we need to clean the data. So we have another process that we're going to send through it to actually clean up that data. There's a lot of errors in the document. Like we said earlier, there's some HTML mixed in there. We don't want that data. We need some extra process to come in and cleanse that. We want to have a separate store for our clean data and for our raw data, right? Because maybe later we want to go back and manipulate that data. So we want to have two separate stores for that. And then as we're thinking about scaling out this system, Celery is pretty awesome. It allows us to distribute this data processing that we're doing to several different machines. You'll hear a lot of other people talk about doing distributed systems today with stuff like Hadoop. Hadoop's awesome. That's great. The problem is we want something that doesn't have a large overhead. This doesn't have a large overhead. It does one job very well. It does queuing very well. That's what we need for this problem. And it also allows us to distribute the jobs on an actual machine across many CPUs. Cool. And then also, at some point, we're going to want to read this data back out of the database. So we're going to use SQL-Alchemy for that. And it has a basic sharding API already built into it. OK, this is awesome. Each database has a specific shard ID. And then when we query for the data, we can go to the specific shard where the data is located. OK, so we have all this data we downloaded. Some of the financial information is from companies in Asia. Some of it's from in Europe. Some of it's from the other continents, for North America, for example. And when the query comes in, I want to get data for this specific company. We can redirect it to the database that has information for just Asia, if that's what we want. And so we want to shard that data in a smart way. Or we could do it alphabetically. We could say, OK, give me all the companies from A to C, and then give me all the companies from D to F, et cetera. Awesome. So let's look at some live code now. Cool. Quickly, I wanted to show you guys. This is not annoying. an example of actually using Beautiful Soup, how easy it is. This is a simple example that I did with the files that I had, and I'll show you an example of the files as well. That'll be really useful. So here's an example of the raw data that we're looking at. So it is an XML type of format, and each individual entry in this has a date and then the actual data. In this example that I'm using, I'm pulling down bond yields. So each of these entries is for this date. The bond yield for the month, the 1 month is this number, and then 3 month, and then 6 month. Bond yields are used whenever you want to calculate the coupon rate for a bond, and it varies from day to day. So that's one entry. And then let's look at how we actually are going to manipulate this entry with Beautiful Soup. So we want to just grab a tag that looks for a new date, and then one that looks for 1 month, rather than having to scale the entire DOM. So this is what our code's going to look like. So first we open the file with the file handler, and we put it directly into Beautiful Soup. Now there's a try except logic here, so that there's 2 versions of Beautiful Soup, Beautiful Soup 4 and Beautiful Soup 3. And so this handles that dependency issue. It loads Beautiful Soup 4 if we have it. If not, we're going to use Beautiful Soup 3. Under the hood, it's using LXML, which is the Python XML library, which actually, under that, is the C library. OK, awesome. We've loaded it all into our Beautiful Soup, and now we can search for what we're actually looking for. So we want to search for a name, which is the name of the tag, and we want it to be equal to this regex that we built. In this case, it's just going to be new date, as we saw in the HTML document, or the XML document. And we want to ignore case and look at multi-line data. So we want to grab all those elements and just iterate over them and print them out. Zip allows us to iterate over multiple different things in a loop. So I want to iterate over these 2 different variables. And there we go. Awesome. So we have each timestamp, and this is the 1 year. We ripped that all out of the document. Pretty easy. Cool. That's Beautiful Soup in a nutshell. Let's look at the tasks that we set up. So we have a couple of different tasks. The first one, we're going to be downloading all the documents. So we set up a request, and we want to use both HTML, HTTP, and HTTPS. We're going to do a GET request, and we set a timeout. And we're going to retry this 5 times. So if we don't get the document, the service is blocking us for some reason, we're going to retry up to 5 times. And then here's our concurrent future logic. One important thing to note about this is we're using the thread pool executor. You can also do a process pull executor. if you want to use processes. In our case, we're not really concerned about the fact that there might be some issues with sharing memory. So we're going to go ahead and use the thread pool executor. And at max, we want to spin up 5 different workers concurrently. Each of them is going to execute the function. The timeout is 60. It's going to take one URL off the stack, the URL stack, process it, and then if it was successful, it's going to try to write that to file. So that's the first step, is our file downloader. And then the next 2 processes that we have is the one to parse documents. It's very simple. We just parse the document in one function, and then in the other function, we're going to actually rip out the elements. So parse just actually makes the soup, and then parse data rips out everything we want. For our cleanse method, we're going to be doing something a little different. In this example, we're going to be actually taking the data, the raw data we have, and we're going to do an aggregation. In this case, we're going to be calculating the bond spot rate. So we have the par rate, and we want to calculate the spot rate. Let's look at that real quickly. Yeah.
Go back to that code
Sure.
that you had before. You are returning true in the parse doc.
Yes.
Where are those objects going, and why don't you need to save them or return them?
Awesome. Awesome question. This is interactive. Feel free to ask questions. So in our actual ingest flow, it looks like this. There's 2 different steps to it. One of them, we want to download all the documents. And then once we've downloaded all the documents, we want to parse all the documents. We don't want to proceed on to the next step of actually parsing the documents until we've correctly downloaded all the documents.
Oh, so this is just checking to see if they work?
Yeah.
Basically?
So there's this really cool thing in Celery called chain. But basically, it allows us to set up dependencies. OK, so we have this task right here. And there's several different tasks. It needs to download each one of these files. We don't want it to continue onto the next task until it's completed that. So that return true means that it successfully completed. And then once that, so right here where it says downloads.get, it's checking the return value of that. And that's where we're seeing the return value is equal to true. So that's where the true is coming back out.
Sure. OK, so then you're going to redo the parsing later.
Yeah, we could have some other we don't have any logic in there right now, but we could have some other logic in there to retry basically if it didn't work for some reason. Go ahead.
You don't have an agent, a user agent listed in your soup code, so I'm assuming that all the sites are full review.
Scraping it down? Yeah. Some sites say you should list a user agent. It just varies by site.
But your experiences for this kind of
Yeah, for these experiences with the SEC site, they don't really care. They have people that run it, jobs on it all the day. The only thing to note is that I think they say to run at night because that's when they're not doing any updating on their documents and stuff. So, yeah.
When you're using the thread pool versus the process pool,
Yeah.
did you run into any forking issues when that was with the process pool when you were running in the Celery worker? Because I know sometimes if there are 2 threads in the Celery worker, it
Yeah.
can process a lot.
I haven't run into any issues running them together yet. One thing that happens that's kind of strange is whenever you get errors that are generated. So whenever you generate errors for that, that might be an issue. But I think you could redo it doing the process pool executor. Yeah, if you ran into some errors. Yeah. Yeah, you'd have to write that yourself. One thing to note is that there is a little bit of retry logic in here already. Let's look at it again. Yeah, right down there at the bottom. So right here, max retries equals 5. If they start rate limiting me or something, I'm going to retry 5 times anyways. I could build some other logic in here to say, OK, wait 30 seconds and then retry again, or something like that. If you had a good setup, you'd want to write this to a log file. And then when you start noticing errors come up in your log file, you'd want to try to fix it.
I guess I'm just interested in how the failures impact the chain.
Oh, yeah, very good question. So right now I don't have anything in there specifically to care about that. Yeah, I've disregarded that in this simple example. But yeah, potentially you could have something in there. If there's a failure, catch the failure, return a false, and then handle that in a retry logic some other way. Yeah. Any other questions? No? Yeah, go ahead.
If I were to run this in Linux or Unix, can I not assign daemons to do the job scheduling? Like, how does Celery have an advantage over that?
Yeah. I think it comes from the distributed functionality of it. So I want to take this and distribute it to hundreds of different machines. That is something that you would traditionally hear someone talk about doing with Hadoop or another platform like that. You can't do that just with regular daemons. It's not going to work. It also uses RabbitMQ under the hood to manage the messaging. That's also not shown here, but yes. OK, I have a few more minutes. OK, cool. So we'll look over a bit more. But I think I kind of laid out most of the basic parts of it for you. Feel free to ask me questions later. But yeah, there's a couple of key points that we talked about. You download all the documents, you parse them. And then if you think about it, I didn't show you this, but well, I did actually. The spot would be our cleansing function. In a traditional data pipeline, you want to have some other task that goes through here that it will actually clean the data. Ours is just aggregating of data. And so it's very simple, actually. It's just reading out all the values that we've collected in our database and then performing the mathematical operation on them. And then it's going to save them into a different table.
That's a lot of magic numbers.
Yeah. For all you finance guys out there, basically what we're doing is we're taking the par curve and then calculating the spot curve for it. So, yeah. Yeah, I got one more minute. Another question.
Self-concurrent features is only available in Python 3.
Yes.
No plan for 2.7.
I think that there is something called async IO, which I think someone else is talking about in another talk. I'm not sure if that also you can do that in Python 2.7. But there may be a way to do it in Python 2.7 as well.
Yeah, there's a lib called features.
Awesome. Oh, yes, that's right. I forgot about that. Yes, there is. Future utils would allow you to do that. That's right. Yeah?
Do you have any thoughts on database versioning?
Database versioning. Yeah, so if you're worried about database versioning, there's a lot of cool, awesome stuff you can do with SQL-Alchemy that allow you to deal with those database issues, those versioning issues. If you have like a schema that changes or something, you can run just like one thing and it'll do it for you. It's very simple. Okay, we're out of time. Thanks, guys.